Okay, so today's 912, and we worked more with composite functions, but we're actually looking at graphs and tables today. It still works the same way. Yesterday we talked about f of g of x, where we took the inside function and plugged it into the outside, so we always start with the inner and move to the outer. So here we're going to do the same thing. We're going to find g of negative 2, which is a positive 3. And then I'm going to find f of 3, and I get 0. So my final answer is 0. Okay? A good illustration might look like this. If I take negative 2 and I plug that into the g function, when I plugged in a negative 2, out of that came a 3, and then I plugged that into the f function, and then out of that came 0. So your output of the original function, of the inner function, becomes the input of the outer function, right here. So let's do a few more. Right here, g of 2, when I plug in a 2, I get a negative 1. And then I find f of negative 1, and I get negative 1. Here they switch it on you. First you're going to find f of negative 1, and I get negative 1. And then I find g of negative 1, and I get about 2.5. F and f, or f of f and g of f, f of f and g of g are basically the same thing, but you're just working with one function. So we're going to find f of 5, which is 0, and then find f of 0, which is negative 1. G of negative 2 is 3, and then g of 3 is negative 1. You can do the same thing with tables. We'll start with the f function. F of 3 is 5. So there's my output of the inner function. And then that output becomes the domain or the input of the second function, or the outer function. So I end up with a 4. Here's f of 4. So when I plug in a 4, I get a 2. Now plug a 2 back into f, and I get a 3. G of 1 is 3. Plug a 3 back into g, and I get a 2. Now here's one with 3 functions, but nothing changes. We always start on the inside and just work our way out. So f of 2 is equal to 3. G of 3 is equal to 2, and then you come back to the f. So f of 2 is equal to 3. I'll go ahead and skip part 3 there. It's the same thing, just looking at graphs. Down here, on part 4 there, we're going to do the same thing. We're graphing f of g of x over here on this coordinate plane. We're going to choose some points here. We can use 0, negative 2. We can use 1, negative 1. We can use 2, 0. And we can use negative 1, negative 3. And I'm also going to choose 3, 1. So there's some points there that we're going to use. So f of g of 0, g of 0 is negative 2, so that says we're going to find f of negative 2. Now the f function is x squared, so I'm going to plug negative 2 into here, and I get 4. So I plugged in a 0 to the original, and I came out with a 4, so 0, 4 is going to be a point on our new graph. Okay, let's choose negative 1. So f of g of negative 1. G of negative 1 is negative 3, so we're finding f of negative 3. When I plug that into the f function, I get 9. So negative 1, 9. We'll say it's somewhere up there. Okay, keep going. F of g of 1. G of 1 is negative 1. So we're finding f of negative 1, and I get a positive 1. F of g of 2. G of 2 is 0, and then I find f of 0, and I get 0. And lastly, we'll take f of g of 3. G of 3 is a positive 1, and when I plug a positive 1 into the f function, I get 1. So, we already graphed 0, 4, we graphed negative 1, 9. Now we're going to graph 1, 1, 2, 0, and 3, 1. So you can see that the graph will look something like this. Okay. Now it says consider what the domain and the range should be. So the domain here for this quadratic is always all real numbers. The range here is 0 to infinity. There's no restrictions on this as far as the domain goes, the linear here. There's no restrictions on a quadratic, so we don't have to worry about that. Remember that our three special cases are the radical, the rational function, and the log graph, or the log function. So down here, on example number 5, we're dealing with a square root. So remember, as far as the domain goes, the rule is the inside cannot be negative. So what you need to realize whenever you're working with composite functions is that the range of the inner function affects the domain of the outer. So right here, if my domain of the square root cannot be negative, then we can't have a negative range down here. So we don't want to mess with any of this, because all of this is the negative range, which would become the negative domain here, which would make this problem undefined. So that's going to cause some discontinuity in our final answer. So we're going to choose points. I'm going to start with these zeros here. So I'm going to take f of g, we'll say that's a negative 0.5, which is f of 0. And when I plug a 0 in there, I get 0. This other one we'll say is 2.5. It's probably a little off, but we'll roll with it. So g of 2.5 is 0. And then the square root of 0 is 0. Then we can choose some other points. Let's see, negative 1, 2. So f of g of negative 1 is f of 2, which is the square root of 2. And then f of g, we can use 3 here, which looks like that's also 2. which is, no, I'm sorry, that should be a 3, which is f of 2, and we also get square root of 2. Let's go ahead and choose one more on each side. So f of g of negative 2. Negative 2 comes up, we'll say that's 6. And then f of 6 would be the square root of 6, or 2 point something. And then I will also choose, we already chose 3, so now I'll choose 4, which is probably 6 as well. So I'll come over here and write it. F of g of 4 is equal to f of 6, which is the square root of 6. So let's graph these points. When I plug in a negative 0.5, I get 0. When I plug in a 2.5, I get 0. When I plug in a negative 1, I get the square root of 2, or 1.4, something right in there. When I plug in a 3, I get square root of 2. Same thing. And then when I plug in a negative 2, I get square root of 6, so 2 point something up here. And when I plug in a 4, I get square root of 6. So we're looking at this graph and this graph. Notice right here, we decided not to use the negative range there because it would make the domain negative here, which would cause this to be undefined. So that right there caused discontinuity from negative 0.5 to positive 2.5. So you've got a break in the graph from negative 0.5 to positive 2.5. So my domain, I'm running out of room here, my domain is negative infinity to negative 0.5. It'll touch there, and then it'll jump over and continue at 2.5 to positive infinity. And then the range is greater than or equal to 0. And there you go. That's working with composite functions, looking at graphs, and then actually graphing composite functions. I hope this helps. Thanks.